I want to thank you, Susan, for inviting me. I am Gina's husband, in case you don't know who I am, you know. And it's like with children, when you grow up, you are the father of so-and-so, and then when you grow up, you are the father of your son, so you start losing your personality. Well, I'm very happy to be here and show you. I have a challenge, is that to try, without the voice, to explain to you what do we do, because it's a little bit crazy. The first thing is we do regenerative medicine, which means that we use your own body to cure your diseases, but also to prevent some of your diseases. So basically, I'm going to show you first who we are and what we're doing. This is super important in the anti-aging, because we will be able to recover cells and regenerate cells that have been dead or are dying. So we are a private company. We were born because we were trying to discover how to grow bone. And the bone that we were able to grow was very little, and it was used for children without any means for cleft palate. And each gram of bone, to be able to regrow bone, cost $7,000. So for us to treat 10 children, cost $70,000 per child, and it was almost impossible to go to Oaxaca or Chiapas and get these kids operated. So one of our scientists that is here, Juan Carlos Lopez Noriega, and Fernanda Villarreal, who is running the company. We are a private company, so we use our own means. We don't use grants, we don't use anything, and that gives us total freedom to go wherever we need to go. So Hint is like the mother of the companies, then is Storacell, because I am a banker. I bank on stem cells. We cryopreserve stem cells. This is part of what we do. And then we have Indebioc, which is where we do the research. And this is why we can see that the iceberg, because you can only see the tip from what I'm going to show you, and the rest is below the surface. Where can we find stem cells? First, let me explain to you what a stem cell is. How many of you have put the umbilical cord of your kids into a bank? You know? Okay. I'm going to give you bad news today. The bad news is that these cells are called hematopoietical cells, and they cannot be reproduced, they cannot grow. So whatever you have in your cord is all you have, and you don't have any more. And it's used for blood problems, for blood diseases. So normally, those cells only are enough for one treatment for a kid that is no more than 16 pounds. So if your sons or daughters are more than 16 pounds, please stop paying, okay? Because it's really not good. And then you can get those cells anyway from the iliac crest. So it's not really a very good idea. Then what am I talking about if stem cells are no good? It's not that they're not good, it's that the hematopoietical cells cannot be reproduced. The other cells that we're using are mesenchymal cells, and I will explain to you a little bit what those are. We can find them in the mucosa, we can find them in fat. So all of us have enough stem cells to give. I wish I could give a few of those to my bank. I want to bank my cells. So we can find these cells practically everywhere, but where they are, the most powerful cells are in the teeth of the children, on the primary dentition of children. And the crazy part is that all the children, when one of the teeth get loose, he puts it under the pillow, and the mice, or I don't know, how do you call it in the States? And the fairy comes and gives a few dollars, And if the father knew how much was that worth, he would give him $200,000. Those cells are very special because they have not been in contact really with the organisms. They're not in contact with any diseases. They're totally pure, and I will show you why it's so important. The way we do it is we say to the people, save your teeth, then we get these cells, we multiply them. We multiply it in medicine, it's called expand, but it's really multiplying them, and then we freeze them. And we freeze them to minus 196 degrees Celsius, which is like 500 and some degrees, and is part of what today there is a new thing called transhumanism, that is, how can we live longer? But not just how can we live longer, but how can we live better? And this is the challenge. And people are challenging these ideas because they say, you are going to produce a problem because how many old people are you going to have if you keep getting old people alive, no? And especially if you're paying pensions in France or in Mexico, so it's a huge problem. But then there is the other question, which is, why is more important a child than an old person? Why cannot we treat them alike? So we believe that this medicine is totally fair for everyone. So we get your cells. This is part of the lab. We have a lab that, first I want to make a commercial, is that we only use Mexican scientists. We collaborate with every university in the world that you can imagine, but all our scientists are Mexicans. And part of the problem was that all these scientists had no work. They have PhDs, and they drive taxis. I mean, it's crazy. So we decided to make sure that we could give every PhD that comes out from UNAM, which is a national university, we hire them, whether we need them in that moment or not. But we make sure that these guys, like these kids, can breathe, can think positive, and they can believe that there is a future. Then we are under every standard, and part of the people ask me, why are you so advanced in Mexico? Is it because you have less regulations than in the States? And I tell them, no, we have exactly the same regulations and sometimes worse. But the authorities have become a little intelligent, and I'll explain to you why. But we are under FDA, GMP, which is a good management tissue practice, and it's lab that you can practically produce anthrax if you want, because the air in this volume, in this laboratory, changes 12 times per hour. And the air inside is 99.99% pure. And then what you're seeing there is something that has air that is 99.99 square pure. So you can imagine that nothing gets in there, no? What we do is we isolate the cells from the dental pulp or from the mucosa or from whatever, but we are very much into these cells, and then we expand them, which, as I explained to you, we grow them, and then we preserve them. What we do is, when we are expanding them, we remove all the information. We check for any diseases. We check for AIDS. We check for genetic diseases. We check everything that you can imagine. I mean, nobody has checked you more than we do one cell. And then once that cell is without any information, which eventually will be very pure, and you will understand what I mean by pure, we expand them and then we preserve them. Minus 196 is minus 321 Fahrenheit. So you can imagine, and this cannot be any variable. And many of the cords originally, they were freezing them very quickly. So they were killing the cells. So this is very important. In 2012, these two guys won the Nobel Prize for the work that we're doing. And it's Yamanaka and Gordon. And they did something called pluripotential cells, which means that from an old cell, they can make it young, they can remove the information, and then that cell can transform in any other cell of your body. this has a problem that these cells don't remember when to stop growing, so they produce tumors. Okay, and the challenge for those IPS called pluripotential cells is that we don't use pluripotential cells. We use mesenchymal cells that are called multipotential. And the reason is because we want to know that these cells will stop growing when your body tells them that it's enough. And we can use them in different type of diseases. Just a few examples. We can produce the bone that I was explaining to you, which, let me check the time. Ooh. Well, we can produce the bone, we can produce beta pancreatic cells that produce insulin, and this beta pancreatic, we put it under the skin, produce the insulin, and we can treat diabetes 1. We can treat with the neural cells, we can treat ALS. Remember the Ice Bucket Challenge? Okay, we are already doing that in Mexico, thanks to a law that allows us for diseases that are called orphan diseases which have no cure. From the day they tell you you have ALS to the day you die, 3 to 5 years, and you die horribly. So we have the way to treat them, so it's crazy that the authorities don't allow you to do that because you have no choice. So we are into that fight. We have also the beta pancreatic cells, cardiomyocytes. You have an infarction, part of your heart dies, we can put you these cells, and by whoever wants to go to the other little longer lecture, I will explain, but those cells go directly to your heart, and they regrow that part of your heart. So it's called regenerative medicine, and that's why. It's used for strokes, it's used for many things. This is how they look under the microscope. This is when we have already changed them. We have given the information to produce neural cells, and these cells can be sensitive and motor neural cells. And it's for Parkinson, Alzheimer, ALS, and strokes, and paralyzed people in accidents and stuff like that. This is very interesting. These are mice that we cut the medulla, and we paralyzed the rats. And then we put, 3 weeks later, human neural cells to the ones in the right, and the ones in the left not. And the ones in the right, they're not just walking, they're walking coordinately. They can coordinate the movement. So that means that the neurotransmitters that we're putting are very, very effective. So this is one. Let me pass it again. Well, this is also another one important one is retinitis pigmentosa and macula, dry macula, which 70% of adults have when they get older. And the retinitis pigmentosa is what Steve Wynn has, that he cannot read. So we're able to stop that, and we can produce rhodopsin producing, which is like the cones that receive light. So we are doing that with Hadassah in Israel. And this is the cardiac cells that once we give them the information, these cells by themselves, they start beating. This is not a heart, this is just a colony of cells that when it starts beating, as you can see, well, look at the other ones. They start beating, and they beat at the same time. They can communicate with each other in a petri dish without any contact. So these cells can make it like a heart. For diabetes, these beta pancreatic cells, very quickly, beta pancreatic cells, your T lymphocytes think that your beta pancreatic cells are an enemy and destroy them. That's why they have diabetes. So we are doing, we put these cells into a capsule that allows insulin to go out, but it doesn't allow the T cells to come in. And that's why we can work with that very well. Also, 99% of adults who still have teeth, they have periodontal disease. And that disease goes directly to your heart, and it's really, really bad. So that, you could not grow that bone. We can grow that bone. So it's quite important. And something that you probably, because I have 14 seconds, you have something very interesting that what we're doing is we are producing a serum that today we can really make your fibroblasts in your face unwrinkle you, to make you younger, kind of, because, but we are not just in the serum, we're also doing it, the next experiment, because the serum and the cream is ready, and we're ready to roll. And the important part is that now we're trying to do it from the inside out, so we're going intravenously, and also we're going to go with a pill. We are not so sure that will work very well because of the acids in the stomach kill these growth factors, which are proteins. But we are into this thing. Sorry, I finished. Thank you.